Hello everyone, and welcome to our demonstration on running scientific applications on the cloud. Today, we will be deploying a scientific application on the Jetstream cloud, a cloud service provided by Indiana University, with the help of Apache Mesos and Mesosphere's Marathon. For those of you who are unfamiliar with Apache Mesos, it allows us to pool the resources of many machines or virtual machines and treat them as a single large computer. Mesosphere's Marathon allows us to launch tasks on Apache Mesos. For this presentation, we will use UCAR's application, which has been Dockerized, in order to run it off the cloud and connect to it via a web browser. In order to launch a task on Mesosphere's Marathon, we need to create a JSON blob that allows us to launch the task. The blob contains an ID, the resources needed by the application being launched, the number of instances, the type of container that it will use. In this case, we'll be using a Docker container. Since we're using a Docker container, we must tell the application where to get the container from. And finally, we need to expose the ports from the internal container to the external host. In this case, we are exposing port 6080 from the internal container to a random port on the host machine. This particular instance will have a user password PASS in order to log in. We will now be sending the JSON blob over to Mesosphere's Marathon in order to launch the task. We can see that Marathon has received our command and is now scheduling our application for launching. Similarly, in Apache Mesos, we can see that the task has been received and is now staging. From here, we can see the standard error and the standard out. Now that the application has launched successfully, we can go back to the main UI of Mesos and see that the container is running. If we return to Marathon, we will now have a link to where this container is running. We will now put in the password. And now we're seeing the graphical user interface of Unidata IDV. While it's loading, I will demonstrate how we can launch a second instance very easily with the help of Marathon. We would like to create a second instance, so we will scale. Once again, the task has been started, and it is already running on Mesos. We can now go to Marathon for the link. Put in our password. We have a second instance launched. Notice that any changes that I apply to this new instance do not affect the other instance. These instances are running in two separate nodes inside the Mesos cluster. One of them is running inside SciGap 3R, while the other one is running inside of SciGap 1R. I will now be handing off the presentation to Julian from Unidata, so you can showcase what an instance of Unidata running in the cloud is capable of.
Hello, this is Julian Chastain from Unidata. I'm going to jump in to talk about the Unidata IDV, or Integrated Data Viewer, just for a minute here. The IDV is an application for geoscience visualization and analysis. The IDV excels at bringing disparate data into one view. For example, one can bring in surface observations, radar, and model or forecast data into one view for comparative analysis. So let's demonstrate an example of this. I'm going to log in to the Jetstream cloud with my credentials, with a URL that's already been provided for me by the Jetstream team. And here we have the IDV. The IDV is composed primarily of a view window, which we see right here, and the IDV dashboard. The dashboard is your workflow tool in the IDV. So for demonstration purposes, I'm going to navigate to the Data Choosers tab. In the Data Choosers tab, there is a panel right here on the left. We're going to select Catalogs. The Catalog node will bring forth this catalog data tree that we're going to navigate to get to our data. We're going to select example bundles from the UCAR Ramada server. Ramada is kind of like Facebook for geoscience data. We're going to connect to it. It has good and tight integration with the IDV, I might add. We're going to connect to it by drilling down and selecting this node and going to the kiosk node. And right here, this brings forth a number of different bundles. Bundles are how you save your work in the IDV. They're basically a collection of data sources and views that have been previously saved. In this case, there's a number of different bundles that have been saved by someone in the past, and we're just going to open up one of these bundles. The bundle that I'm going to choose to load is the very first one, the IR MSLP Water Vapor Precipitation Bundle. We're going to go down here and click Add Source after we've selected our bundle. Here we're asked a number of different questions about how we want to open the bundle. We're just going to click OK. After a few moments, our data have rendered on the globe view. At this point, I'm going to bring in my colleague here at Unidata, Jeff Weber, to talk about what you're seeing in front of you at this moment. Take it away, Jeff.
What we're looking at here is a globe display of both satellite imagery in the infrared band as well as model output. We're looking at the GFS, the Global Forecast System, half-degree model output. The global view offers many different views of interesting features. Some wonderful things to look at on the global view are these large pressure fields represented by either the red and orange indicating high pressure or the blues and the greens representing low pressure. The synoptic pattern, or these large-scale pressure fields that are on the size of continents, generally dictate the patterns of storms and the relationship of warm and cold weather interacting with each other. Another strong feature here that we can look at in the satellite imagery and also purveying into the model output is the intertropical convergence zone. Here we're seeing the northern and southern hemispheres coming together and creating convection along the equator. This is a persistent pattern that exists throughout the entire year while migrating north and south seasonally.